Biology, Part 138. In recent years, there has been a tendency to apply the discoveries of sociobiology rather uncritically to human behavior, for example, to explain differences in social roles of men and women. However, the evolutionary study of the social behavior gives only limited insights because so much of human experience depends on the cultural factors accumulated over thousands of years for the civilization. Well, we can have further discussion on the same. We can either reject the Darwinian theory of evolution, or we can modify the Darwinian theory of evolution. Darwin has given an evolution theory, and there are people of different classes, different opinions, different thoughts who either modify it or reject it or establish it. So anyhow, now we move on to our next topic, which is the origin and diversity of life. So now we talk about the origin and diversity of life. A very important topic, of course. Origin of life. The formation of Earth. Well, it explains that the tutorial will explain that one of the most probable sequence of the events from the earliest beginnings of life on Earth to the present day. It is not intended to answer all the possible objections or to explore the alternatives, but simply to present a summary along with some of the more important pieces of supporting evidence. The Earth was found between 4,500 years to 5,000. So let me put it again. The Earth was found between 4,500 million years ago to 5,000 million years ago from a cloud of dust particles surrounding the Sun. As the mass of the planet increased, heat generated by gravitational compression and radioactivity decay caused the interior melt, producing a dense molten iron and mickly core. This is how the Earth was formed. This was surrounded by the cooler liquid mantle of the iron magnesium silicate. The outermost layer, or the crust consisting of the lighting silicate compound, solidified to form the continent and the sea floor. As the cooling process continued, the gases from the hot interior escaped through the volcanoes, forming an atmosphere consisting of hydrogen, water vapors, methane, ammonia, nitrogen, hydrogen, sulfide. This mixture of the gases had strong chemical reducing properties and was quite unlike the atmosphere today that we enjoy. In particular, oxygen was missing. At about the same time, 500 million years ago, oxygen was not there in the atmosphere, and there were large quantities of water vapor condensed to the form of the oceans. Synthesis of the organic chemicals. Many of the chemicals needed as subunits for making biologically useful molecules are thought to have been formed in the shallow waters of the oceans as the products of chemical reactions between simple inorganic substances. The probable nature of these reactions was first demonstrated by an American scientist, Stanley Miller, in 1953. He set up the experiments illustrated in the figure, intending to recreate the conditions of the Earth before the life evolved. The essential components of his model system were a mixture of gases simulating the primitive atmosphere, water, and an external energy source. A number of the possible natural energies surrounded the existed, such ultraviolet lighting and radiation. In Miller's apparatus, gases, waters, vapors were all exposed to the spark discharge, and they represented lighting. Following this, the water was condensed, then boiled and recirculated. After a week, the solution in the apparatus was found to contain a variety of organic compounds, including the amino acids glycine, alanine, lactic acid, and urea.